database, tables, partitions, sorry, yeah, partitions, and then buckets. So we have already covered creating a database in Hive and created tables using row format delimited as well as sequential file format. And we have written some DML statements using load data, load from an external file into table, and after that insert into as well, right? And this is what we have covered in the last class. So I hope everybody practiced it, probably joins and other SQL statements as well. Today we will cover basically partitions. Probably theory we will cover everything. Theory, partitions, buckets, and complex data types as well. And practical part to cover partitions. And probably I will record the buckets and complex data types and upload into YouTube. Probably you can go through the buckets and complex data types. Yeah, is it fine? Just say yes. Hope you can send a message. Yeah. So what to cover is basically theory part will cover partitions and buckets. With this will complete all the different Hive data models. So already covered database tables and partition buckets. And apart from that, we'll cover complex data types theory as well. And practical, we will go to practical of partitions. And I will record for buckets and complex data types. Yeah, then let's go to partitions. So basically, Hive is a high-level language on top of MapReduce, as you are aware. So MapReduce is basically batch processing engine, and it scans the entire table, right? As it doesn't support random access. So now, when you give a select statement, it has to scan the entire table, even though your select statement returns few records, because MapReduce is a batch processing engine. Right? So that's about next this thing. So simple query in Hive reads the entire data set, even if you have a where clause filter. Right? So this becomes a bottleneck for running MapReduce over a large tables. So this can be basically um, overcome by using partitions. I think partitions is not very new to Hive. Partitions are also there in SQL Server. Let's say we have a table. So partition is, let's say, if you have a table, for table has a records for different countries. So when you create a partition on, when you create a partition basically on a state, right, or a country. So data against each country will be stored separately. So when you are retrieving the data, let's say if in my filter criteria, if I use where country equal to India, so as the data is stored separately for India, it need not scan the entire page, just it has to scan the data against the country India and will fetch it for you. So the performance of your select queries are much better rather a table that is not partitioned. So I mean, that's basically, it's there in all relational databases as well. SQL Server support partitions. I think Oracle also should support partitions. So same thing can be implemented in Hive as well. So in Hive, basically there are two different. Just before you go forward, by default, if we have a table that is partitioned, it doesn't support getting the data from different partitions. Now we have to specify in the where clause partition class. Let's say we have a table that is partitioned by country. So we cannot write a statement, select statement, where your query has to fetch the data across different partitions. Now these restrictions can be removed by setting the following options. Now set commands. No, these are the set commands you have to uh, run to remove the restriction of running a query that gets the data across different partitions. Right? Bob will cover buckets later. These are the two options you have to set so that it doesn't complain when you run the query that fetches data across different partitions. Yeah. Right? I mean, that's basically, you have to set these partitions. And if you go to Hive partitions, there are two types of partitions. No? Hive supports two different type of partitions. Number one is static, two is dynamic. So let's go to the syntax of static. Right? When we are loading data into static partition, let's say first let's go through the syntax for creating a table. Right? Uh, the create table, same as what you have covered before. We have to include a partition by, basically a partition by emp location. In this case, let me go my data. So what you have is employee ID, employee name, salary, department number, and let's say country. So we will partition the data by country so that data against India basically stored in a single partition. Data against USA, it will be stored against a different partition, and France, it will create a different partition. So data for India stored together in one partition, USA in other partition, so on and so forth. So now we want to create a table with employee location as your partition column, right? If at all you want to create a table with employee location as partition column, this is the syntax, right? This is common so far. Create table, table name, all the column list, and partition by employee location. This is it based on what's the format of your input data. So row format delimited. Our fields are terminated by comma and lines terminated by new line character. So if you observe here, right, this partition column is not in the create column list. We need not mention the partition column in the create table column list. You have a different clause partition by, just include the employee location or a partition column here, right? And yeah, and then probably by loading, right? This is basically static partition. Load the data and you will mention here partition emp location equal to India. This is basically we are hard coding in this case. So what you are saying is your table or whatever the data, it doesn't have a partition column in the file. Just we will say that whatever the data I am loading is against the partition India, and here against the country USA. You have to mention when you are loading the data. So because basically you are hard coding the employee location in this case. This is basically uh, static, static partition. Yeah, I mean that's basically static partition, and dynamic partition basically we don't mention while inserting we need not mention uh, the table for which partition you are inserting the data. So it's all dynamic. Now you create a partition by column, and we will insert the data. Basically, this is basically a dynamic partition, right? And yeah, but in case of dynamic partition, there are advantages and disadvantages, but data is not distributed evenly. Let's say your partition column is based on the country, right? We might be getting huge volumes of data against one country, and not so much of data against other country. Still, the data is partitioned by your country column. So the data is not evenly distributed across different partitions, right? Because you have more data for one partition compared to other partition column. And apart from that, probably it's a very common that if you have because the number of partitions are based on distinct values against your partition column. In this case, employee location is your partition column. The number of partitions that will be created is equal to distinct values against your employee location. So if you have a table that has in your partition column, if it has so many distinct values, and it's not recommended to create a partition column. So at least whatever applications have worked, now we don't create a partition column against a column that has more than 50 distinct values, probably not more than that. So if you want to limit the number of segregations, then there are other option available in Hive. So before I move forward to buckets, so do you have any questions in partition?
So Venkat, if we create, if column has a very so many distinct values, so we don't go for partition. You're saying, right? So
Yes, it's not
generally in
recommended to
real time,
partition. Yes, correct.
yeah, but in real time matter, we would be having for a particular column, we would be having a huge number of distinct data, right?
Yes, but usually the partition, let's say we are getting the data from different countries, right? We do a
Mm-hmm.
partition based on the country column, rather a column that has more distant values. That is how
So we
usually
need
the
to evaluate, or we need to make a decision based on our data. So what columns into do partition?
yes, correct. You are the one who is deciding. Usually, we'll go with a partition column that doesn't have more distant values. Now, you can do it by year,
Okay.
month. That usually, if I want to store all my data for a specific month against one partition column. So, usually, now this is one of the partition column used. You can do it by a month, year, or a month, quarter. So we don't have many distant values. Now, definitely you cannot create a partition column on uh, basically uh, customer, right? So many
Mm-hmm.
customers, you don't want to create so many partition columns because the data is stored in a different partition. So basically, we want to split our table. Let's say our table is huge table. We want to split into small partitions. We don't want to split into so many partitions, but rather we want to split into small chunks of let's 30 chunks, partitions. So it's recommended to create a partition column on a table that doesn't have more distant values.
So impacting, it will be slow, right?
Sorry, what is
We
slow?
can, uh, if you do a partition on a column which has so many distinct values, if we do that, impacts the performance, right?
Not the
While
performance,
fetching.
it's not recommended first of all, right? We don't want to split our table into small uh, kind of logical storage, right? Let's say
Okay.
if you have a,
Right, right.
so even see your partition column is based on your data access pattern, right? If you
Right,
want to
right.
retrieve the data for a specific country, right, specific region,
Mhm.
right, we will create a partition column on that table column, right? Let's say we
Okay.
have users across different countries, right? Probably India user most of the time he will access only India data, not uh, other country data. To create a partition column against against the country, so we don't have so many partitions, probably 100, 200, whatever, 300 maximum, right? So
Okay.
while retrieving, it will be performance will be much better because we don't scan the entire table. We will scan only the data
Okay.
against the country India. Yeah.
Right. But in worst case scenario, Venkat, let's say I'm a bad programmer, but I have written a partition on a huge distinct values column.
Yeah,
So how's
but
it going to happen?
yeah, I think as Aparna pointed out, no, this is not uh, probably this station is not made at the developer level. This is something that is made
Okay.
at a higher level, right? And it
Mm-hmm.
depends on your data access pattern. And we will definitely will take a right decision choosing the appropriate column as a partition column.
Okay. Sure. Go to. Thanks.
Yeah, right. And dynamic and static partition. In static, it's hard coded. Partition column value is hard coded. Then insert loading data into table. It's not hard coded. Right? And Hive buckets. I mean, this kind of buckets is not supported in other databases like SQL Server and Oracle. I'm not sure about Oracle, but definitely there's no option of buckets in case of SQL Server. And Hive it also provides something like a buckets. The advantage of Hive is buckets is basically we can limit the number of buckets. Let's say I have a data against a table. I want to have a small buckets. Total number of buckets should be 30, something like 40, right? We can limit in case of buckets. This cannot be done basically in partitions because partition is based on a distant values against your partition column. So in this case you can limit the number of buckets against a table. Let's have a huge table. I want to have 10 buckets. This is something regardless of any column, we always have only 10 buckets, right? And partitioning, if it is partition is a possible that you can create multiple small partitions based on column values. This is what I was trying to explain. If you are bucketing, you are just restricting number of buckets to store the data, right? This number is defined during table creation steps. So, and buckets are used probably let's say as I mentioned, right, if we have a table column that has a large number of distant values against a column, then you can use the buckets to restrict the number of small chunks of your data. So that's the difference, basically difference between a partition and a buckets. So the syntax for creating the table, that's called buckets. Now this is the syntax, and here the difference between the syntax of partition and buckets is In the create table column list, we will mention the column that you want to partition, and also in the clustered by clause. If you see, in case of partition, whatever column you are partitioning, that is not listed in the create column list. But in the case of buckets table creation, you will mention the column that is used to do bucketing. It's also mentioned in the table creation list, column list, as well as in the clustered by clause. So clustered by clause is basically used to create some buckets, and you are saying just create 3 buckets out of my total data in the table. Right? Let me
Good.
yeah. So at a high level, what again? Let me write it down here. Right, buckets. So buckets are basically used for sampling data. Right? Is one this thing, and we can restrict number of buckets. Right? So number of buckets will be specified in the create table. Create table statement. Right? When you talk more about the statement, syntax for the statement, in case of buckets, we will mention the column that you are bucketing both in the column list as well as the clustered by clause. So in case of partition column, we don't mention the partition column in the create table column list, and will mention only by partition by clause. I just want to highlight here. Right here in this case, right, your employee location is not specified here. You don't have employee location here. But in case of buckets, we will mention your department number, right, both in the column list as well as a clustered by clause. Right? I want to do this. So bucketing works well, right, when the field has high cardinality. What do you mean by high cardinality is if you have a more distant values, right, still we can limit to the number of buckets to 10, 15, whatever. Even it has a distant values of 100, still you can restrict to 10, 15 based on your requirement. So unlike unlike in partition where it is based on number of distant values. And partitioning is best when you have only a few number of distant values against your partition column. Right? And in case of partitions, data is not distributed evenly among different partitions, because you could have huge volumes of data against one partition column compared to other partition column. Yeah, but buckets are not supported, at least in SQL Server. So I think partitions are supported by most of the RDBMS databases, but something buckets is something new in case of Hive. So any questions?
No, Venkat.
Okay.
No,
Uh,
Venkat.
yeah, then probably go through the other what are the different data types in Hive. I think you have already gone through kind of data types like numbers, simple data types like numbers, string, decimal, date. Those are already covered, and you have a complex data types as well. What are different types of complex data types? Different
arrays, structures.
Yes. Yeah. Just I'm muting everyone. Probably, yeah. I'll ask questions. We have a struct and map and list, right? Kind of array. Right. Let me go to here. I'll cover everything, accessing bucket information. Probably in the practical of buckets, I will record it. And to give you this thing, let's say you have bucketed the data. So sorry, probably let me go back to buckets as well. How to retrieve the data? I think what I've covered is how to create a different buckets. So while retrieving data, we can say something like this. Select star from whatever bucket, a table sample bucket 3 out of 3, because we are segregating our table into 3 small chunks of data. If I want to get the third bucket data, you can get the bucket data. Now, bucket 3 out of 3 on department number. Right. Similarly, these other options get the percentage of data. Let's say I have huge volumes of data, right? I want to get 10% of the data. What you can do is select start from employee bucket table sample, get me 10% of the data. This is how you retrieve the data. But in case of partition, it's a straightforward. We will give a filter on a partition column. In this case, it supports different options, getting data against a specific bucket. Let's say we have 3 buckets, it will create 3 different chunks of data. I can get bucket 1, bucket 2, bucket 3, either one of the buckets. And other way is basically we can get the percentage of data, 30% data, 20% data. Right? That is how we retrieve the data. Yeah. So yeah, complex data types. What you have is a struct, right? As a struct, map, and array, right? What I call array or list. It's array. Struct is basically we are giving a structure. Let's say we have an employee information. We have employee ID. Usually, let's say primary key. We have an employee number, salary, department number. Right? We can access all these columns: employee number, salary, and department as an individual columns. Or what you can create is you can create a struct like a structure as employee, which has all these individual columns. You can create a structure employee and employee as employee name, salary, department number. So rather than accessing individual columns, we can group all these columns into a structure called employee. Right? Then we can access each column using, let's say my structure name is employee, so employee dot employee name, you will access what using dot notation, access each field in struct with dot, right? So what you can do is we can group individual columns, let's say employee name, employee salary, department number into struct employee, right? So after you create a structure, uh, combine all these columns into a structure, we can access using dot notation, right? So example, you can say access each field, in this case employee name, etc., using dot notation. So we can access using employee dot e name. Right? This is how structures will work, right? And the other thing is a map. Map is basically key value pair. Map is key value pair. Right? I think the example I've taken is the phone number, right? What you can have is a landline phone number, right? Sorry, or mobile, or probably address, probably where you can use key value pair. So if at all I want to get a landline phone number, what you go, let's say the name of the map is, let's say name of the map is phone, right? So while retrieving, I can retrieve phone using landline or phone using mobile. So this is your key. Basically, landline is our key and mobile is our key, right? And you will get the value against this mobile. No, that's basically a key value. No, you use a key to store it while retrieving. You get the value against that key. Right? That's basically a map. Probably you can use other areas like address. We have official address or permanent address, present address. Probably you can use a map in that case also. And if you want to get the present address, you can retrieve using map of present address and map of permanent address and array. So and array is basically, let's say we have many elements. Probably what you can say is, let's say marks. Let's say skill set. That's what I've taken, probably in line with whatever the example I've taken. Let's say skill set, right? Probably your skill set is, Java, SQL Server, Hadoop, MapReduce, so forth, big high, right? What you can do is you can create a distinct column. That is how you create, probably in case of relational databases, we cannot create skill set 1, skill set 2, skill set 3, something like that. It's not, uh, you shouldn't design the tables like this, like that, basically in case of relational databases. Probably called rules is no repetitive groups or multiple value columns. So fortunately, in case of Hive, it supports something like a collection, array. You have only one column, and you can have multiple values against that column. So example is skill set. So let's say our skill set is our skill set. Let's say, right? We know basically C#, sorry, Java, SQL Server. Right? I mean, you can store more than one value in an array or a collection while retrieving use skill set of 0, skill set of 1. Skill set of 0 will give C#. Skill set of 1 will give Java, so on and so forth. Yeah, I mean, yes, that's basically, regarding high complex data types. Structures are basically, you can access a structured elements using a dot notation. Map is key value pair, and array is we can store more than one value, and you can retrieve using an index 0, 1, 2 while retrieving the data stored in an array. So, any questions? Again, right? So what all you've covered is partition, static and dynamic, buckets, right? And the third one is complex data types in Hive. Get struct, array, and map. So with this, you have covered all the data models in Hive. Database, tables, partitions, and buckets, and also covered all data types in Hive. Simple data types like number data types in tiny and float, double, decimal, right, and also complex data types. Yeah, now probably do some demo on partitions. First, start with static. Right? So let me start Hadoop and all services. We're starting Hadoop services. Let me open one more terminal for Hive. We'll talk about now the data. We'll use it here. Let me go here. Right, I'm using EMP India data and EMP USA data to load the data into my Hive static partition table. Right. So while loading itself, I will mention what partition column data I'm storing. That's basically static partitions. Yeah, if the Hive everything started, probably you can start it. Still it's running. I hope it's clear about the data. The input data we'll be using is empindia.txt, empusa.txt, right? And it has the data only for India. So while loading the data, we will mention I am loading the data against India. Right? That is how static partition will work. Similarly, I'm loading the data for EMP USA. Just if it all in safe mode, will come out. DFS admin minus safe mode. Yeah, Hive. We're in Hive prompt now. Show databases. Show databases. I think we have used Hadoop class 2, right? I'm using the database Hadoop class 2. Class 2. And I think I have already some, rather than typing everything, I will use. Let me create tables, show tables. TMP copy. And let me create the table. Create table emp static. So our input file has emp id, emp number, let's say emp number, int, emp name, string, salary, double, tept number, int, right? Please note here in the partition, our partition column, we have not mentioned in the column list. Now use a partitioned by class. But partitioned by, you can give any emp, let's say emp location, emp location, string, okay, row format delimited. When you use the syntax row format delimited, we have to mention fields terminated by that comma is the fields terminated by comma, right? Lines terminated by Euler character. I think this, yeah, let me check now. I don't want to make mistake here. Right, line generated by this. So create table, my table is employee static, and the column list. The column list doesn't include your partition column. Use a partitioned by clause to partition data by a partition column, partitioned by and partition column name, and row format delimited. This is all part of create table syntax. Right, now describe the table. It should say, what table is partitioned by employee location as well. Let's describe it. Emp static. Right, it's also mentions your partition by column. Right? Now load the data. Right? So I think I will use here, and but my column name I think I've used EMP LOC. Load this data. And I'm using the same files as well. Just load this. Load data local in path because my input file is in local directory, not in HDFS. So I'm using the local. Right? So point to note here is your partition column we are hard coding. So what you're saying is whatever data I'm loading, it's for the partition India, right? And EMP location. So my column name is EMP location equal to India. Sorry. EMP static. What is the table I've created? EMP static. Partition column is right. And similarly, load the data for yeah. Any questions so far before I go through how actually the data will be stored? Intentionally, I have not covered during the 3D because I will show you how the data is stored for each partition. So, do you have any questions before I go forward and show how data is actually stored?
So Venkat, here we are storing employee USA.txt and employee India.txt files separately into the partitions, right? So let's say I
No,
have
no, no,
employee
just wait.
employee data.
Sorry, Sampath. Here, right? Internally, right, Hive stores each partition data in a separate file. So when you are accessing the data, it need not scan the entire table data. Rather, it just go to the file that has that specific partition data and retrieve data for you.
Correct. So
So, yeah.
my my question is, we have loaded employee emp.usa.txt, emp.india.txt separately into two partitions, that is India and USA respectively.
Yes,
The thing
correct.
is that what I'm saying, can we have a text file data like emp.txt which has data for India and USA and load them into two partitions or multiple partitions?
No, no, no. Because if that cannot be done because let's say you what it's a logical. If you have a data for EM file for both the employee locations
Partitions.
USA and India, right? Because
Mm-hmm.
here the syntax supports I am loading data for one column value. Right? There is no syntax that supports more than one column value. If that is the case,
So
you should go with the dynamic partition. The dynamic partition is there. Just use the dynamic partition.
So here can't load. So when we have a mp.txt and now I'm loading for partition USA, it will scan only USA, and then when we do for India, it will do for India. Doesn't do like that?
It does it in case of dynamic partition. That's what dynamic partition is there. This is static.
Okay, 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 yeah, okay. Go ahead.
Yeah, yeah.
Thanks you.
Let me run this, otherwise this thing I forgot this one. Let's everything at these value this thing also. Let me run this one. Otherwise I don't want these errors. So buckets is not required, but still I think I have to run this. We're clear why we're running these set statements, right? Any questions here?
Yes.
Let me go through how data is stored here. Yeah, I think again I want to cover this is basically the root directory for the Hive, right? This is it's basically root directory. Under this, our data will be stored, right? Our database is Hive class Hadoop class 2, I think, right? And this already covered in the previous class, employee and employee copy, employee static, right? See, basically, this is stored in a separate file. EMP location equal to India, EMP location is equal to USA. So it addresses the problem of scanning the entire data, India and USA. Let's say if your data is not partition, everything will be stored in a single file. So even when you are getting the data for India, it has to scan the entire table. So basically what I have done here is static one, probably if you cover dynamic, then also it's clear that even if one insert statement, it creates a multiple files, one for each partition, right? So this is how Hive internally stores the data to avoid not to scan the entire table data, rather only the data for a specific partition. So any questions before I move forward to dynamic partition? Or when you cover dynamic partition, even there's only one load statement, till it creates different files, one for each partition.
So Venkat, can we view this partition data?
Yes, you can view it, but again, just I don't want to view it because this is not directly you can see it. Now again, I have to download and all. No, it's
Oh, okay.
yeah,
Okay.
you can view it. Nothing, right? EMP India.txt. Right? It doesn't show up here, right? Here again, it lost to download, blah blah blah. Right? This is all.
Okay.
Yeah.
Okay.
So let's move to a
Okay.
dynamic partition, right? Stop Hadoop services, and what I've done is step two. So done is created static partition table, right, and loaded data. Right, now covered dynamic partition. Probably you can select data. Let's see. Select select star from emp static where emp location equal to USC. And that's basically this thing. And I will probably create a dynamic partition table. We have other tables as well. Show tables. This is data. Probably I will use the table. Select star from employee. Right. If you see this case, all the data is stored in a single file. Probably I will show you how the data is stored for this. Now probably I will create a dynamic partition table and load data from this employee table, which has data for against different countries. Right. So, and let me create a dynamic table first. Right. Step one. Dynamic. Let's say EMP dynamic. EMP number, int, EMP name, string, salary double, PPT number, int, right? Partition by EMP location, string. Just I want to store because I load from a different file, stored as sequential file. I don't load from a file. So sequence file. Create table name, column list. So column list doesn't have the partition column, partition by class to partition by employee location, stored as sequence file. And show tables. Employee dynamic. Now let me load the data, because if you see our table employee, everything stored in a single file because the table is not partitioned. Let's say describe it here. Describe employee dynamic. And this is again partition by EMP location. Right? Partition by your EMP location. And now load the data. Insert into table. For the table name, EMP dynamic. See the syntax for loading: partition, right? Partition. Our column EMP location. Select. Let me check my employee table. Select star from employee. Let's say select star. Let's say select. I will say select star from employee. Select star from employee. Right now we're inserting into dynamic table. EMP dynamic. Let's insert into table is missing. partition. See, if you see here, I think the one spelling is wrong. I think no. I think it's saying four distinct values. I think spelling is wrong for France. I think right. That's why it has created four partitions. Then what you have expected only three partitions. So we thought it was storing data for India, USA, and France. So there are four distinct values. For each one, it will be stored in a different file. So employee location France with A, something mistake I think, India, USA and this. And it also mentioned the number of rows against each partition as well. So let me go through the file. Let me go through how the data is stored. EMP dynamic, right? See, for each thing we have a separate file. So when I select the data for India, it will scan only this file rather the entire file. That's what the advantage of partitions, because MapReduce is a batch processing engine. It has to scan the entire table or entire file rather to get what you want, because it doesn't support random access. So how we have addressed is using a partition, because now rather than creating a one file, we have created multiple files. One file stored data against one partition column. So when you retrieve the data for that partition column value, it need not scan the entire file, because you have created separate files for each partition. That is how it internally stores the data. So it need not scan the entire table. Right? So there are four partitions. Each partition data is stored in a separate file. So let me show you for the employee table as well, where data is stored in a single file. Right? So in this case, the entire data is stored in a single file. So when you give a statement for USA also, it has to scan a file that has all the data against all the countries. So that's basically the difference between how internal storage will happen in case of a partition tables and um, a table that has no partition column. So because of partition column, it creates a multiple files. So it improves your deep performance. Right? So that's basically the internal storage, to address, no, not to scan the entire file. So any questions? Probably let me unmute you.
No, Venkat. Somebody here. I don't have any questions.
Yeah, Srinivas, Aparna, any questions? I think Aparna offline. I think no, I'm not sure. Offline. Yes, Srinivas, any questions?
Shiva, Venkat looks like he has some problem, but he is online. He cannot ask questions actually.
Okay, okay, that's
He has
fine.
some problem with his machine.
Okay.
Yeah, yeah.
So probably what you covered is also this one, a dynamic table and load data into dynamic table. Right? Also went through how data is internally stored in partition tables to avoid sorry, to avoid scanning entire table, entire table or a file. So difference data storage between partition table so any questions? Any more questions? Probably.
No, Shiva. Good. I'm good. Should be
Okay
fine.
then. Okay then. I think Aparna is offline. I think Srinivas also don't have any questions. Um, yeah, then probably that's it. End of this thing. What I've covered is partitions, theory of buckets, and buckets and completed types. And probably I will record the demo of buckets and complex data types and probably send
Okay.
it across to our email. Probably you can go through them. If you have any questions,
Okay.
you can come back and ask questions.
Okay, Venkat. Sure. Yeah.
Is it good? Do you think any problem of these videos? The advantage of these videos is you can refer anytime. And probably
Right.
I'm writing everything so that even probably this will be useful. Probably the running board or whatever you call, when I'm teaching what I'm writing, everything I'm
Correct.
saving so that I will share this one as well. Probably that should be useful. I
Yeah,
think.
that will be good. That will be good. Yeah.
Yeah.
Yeah. Venkat.
Yeah. Thanks, Sampath. Any questions? Any before you end?
No, Venkat. Even
Okay.
Srinivas also on it, but he's not able to ask
Okay. Okay.
questions.
And one more thing. Can you have a class tomorrow?
Yeah, sure.
Yeah, probably.
Sure,
Can
Venkat.
Sampath, can you please coordinate with everybody so that let me know the timing
Yeah.
so that we can.
Sure, Venkat.
Yeah, yeah.
So what are the feasible timings for you tomorrow,
In the
Venkat?
same time, probably
Same time?
before same time.
Okay.
Fine with Srinivas
Sure, Venkat.
tomorrow same time.
I'll coordinate with these guys and I'll let you know. I'll
Okay.
confirm you.
Okay. Thanks.
Okay.
Yeah.
Thanks, Venkat.
I will upload this video. Yeah, and we'll share it.
Sure. Yeah, sure.
Thank you.
Thanks.